We are building a trust-scalable system powered by a networked set of homogeneous blockchains based on our WasmX engine. Our WasmX engine is a WebAssembly-based, upgradable, and customizable blockchain core that can be extended through WasM modules. It is compatible with both Cosmos and Ethereum blockchains. In fact, WasmX uses the Cosmos base app while re-implementing all additional modules as WasM contracts. Now imagine a hierarchy of blockchain levels without going into much detail. The higher the level, the sparser the information on that chain. The highest level contains mostly proofs of the activity on the lower chains and aggregate data from the lower chains. The higher levels are also a trust provider for the lower level chains, and the lower level chains hold the actual data, and they can be scaled independently. Lower levels can have more independence as to their rules of use, and they can eventually choose whether or not to be part of this hierarchy. This type of system can reach instant national scale voting for the country of France with 2,200 validators. And this is just 0.4% of the number of validators that Ethereum has. Also, these levels can communicate through cross-chain transactions. And this is what I will demo today. Let's create the simplest local setup. So we have already done a setup with 3 validators on the Mythos testnet, and with a minimum of 1 validator for each subchain that is created. So now we will start the nodes, and then we will run this setup for creating 2 levels, each of the levels having 1 validator. And when I say levels, I mean a chain per level. And we can execute this on the Mythos local chain because this is where the multi-chain registry is. And this is a registry where we can register new chains, and the multi-chain registry generates a default Genesis setup for each chain. And we see the Mythos testnet running, so we can run this command, which will first start registering a new subchain. It gives it a chain base name, the denomination unit, the decimals of the gas token, and some other initial balances that we have. And then we start querying to see if this subchain was created, and it has been created. And this is the new chain ID of the subchain, chain 0 on level 1 with this EVM ID and this fork number. And now we will register another subchain validator, which is actually the first validator, and we are waiting for this transaction to be mined. And after we have enough validators for the subchain can be initialized. Now on Mythos, the subchain initialization is just the triggering of an event. And now we have registered our validator. The event on Mythos is then caught by each node, and each node can decide whether to initialize the subchain or not. And we should see the subchains being initialized. For example, these are the initializing subchain events that are triggered. And we can see a new subchain has been created with this chain ID. And this particular node is validating the new subchain because it's the only validator for that subchain at this point. And this is where the initializing has been done, and we can see the second level chain has also been created, a level 2 chain with the EVM ID 1002. So our chains have been created. Now, generally, only the nodes who are validators on Mythos are by default the nodes allowed, the users allowed to initialize a subchain. So with the same software, we are actually running multiple chains here. We're running Mythos, we are running the level 1 chain and the level 2 chain. And we are also running a level 0 chain, which is a private blockchain, private only to this device. And now we can demonstrate communication between the level 1 and the level 2 chains. So let's deploy some contracts on these two chains. And I will start with deploying a new simple storage contract on the level 1 chain, which is the chain starting with chain 0, 1. This is its ID. And I also mentioned the registry chain ID. So this is needed because the registry contains information about our level 1 chain, like address prefixes and denominations for tokens and so on. So we are sending this store transaction here, and we should see an event store code, and the code ID is 50. So now we can instantiate this code ID code ID 50. There is no initialization data with the label simple storage. So this is a simple storage contract. After we initialize it, we should get an address. Instantiate. Let's see. Contract address. This is our contract address. And now we will deploy a contract on level 2. And this contract is able to do a cross-chain transaction to level 1. We deploy it. Again, we can look for the store code event and see that the code ID is also 50 on this new chain. And we will also instantiate this contract here. And this is on the level 2 chain. And we can see the contract address here. Okay, Let's look a bit at these two contracts. This is the simple storage contract. It just has a couple of methods for setting and getting a variable based on a key that we give. And this is the contract for testing the cross-chain transaction. It has a method that says cross-chain, and this will do a cross-chain transaction with the request that we send. And it does the cross-chain transaction by calling a core contract that knows how to do these type of transactions. So what we will do next is actually set a variable in the simple storage contract. So we are doing a contract execution on the level 1 simple storage contract, setting for the key hello the value Brian. And we will be running this, and to see that it worked, we will also do a query. So querying the same contract with the key hello. And we see the value is Brian. Okay, now for the atomic and cross-chain transactions. Cross-chain transactions are part of what we call atomic transactions. And I have a CLI command that makes it easy to create these atomic transactions from a JSON file. And essentially, this is the atomic transaction command. So we are calling the cross-chain method on this level 2 contract, which is the cross-chain test contract. And this is the level 2 chain ID. This is the actual cross-chain request that we are sending. We are sending it to the simple storage contract, and this is the message that we are sending. And this contract is on the level 1 chain. Now we are going to decode the message that we are sending, and this message will just set the value Sammy for the hello key. So let's continue here and send the atomic transaction. So we already see that the atomic transaction is in execution here. First, it was added to the mempool on the level 2 chain, which is considered the leader chain. The leader chain is the chain that first triggers the execution of this atomic transaction. Next, we see that the atomic transaction is in execution on the leader chain. And then it was also added to the mempool of the level 1 chain. So what happens is the follower chains see this transaction, they try to add it to their mempools, and they will execute it only if the leader has started execution. So because it is already in execution on the leader chain, then the follower chain can also start. So right now we are inside the atomic transaction, and our level 1 chain has just received the cross-chain internal request from the level 2 chain. So we also have some logs here from the simple storage contract, and we can see that the simple storage contract has been called with the method set, and for the key hello, it has set the value to Sammy. And now it is sending the response back to the level 2 chain. And now the blocks are finalizing. So the level 1 chain is finalizing its block, and we can see in the logs of that block the message execute atomic request. And now the level 2 chain is finalizing its block, and we can see the same events for the atomic transaction in that block. And it is done. So now what we should do is query the simple storage contract with the hello key, and we can see that it has been changed from Brian to Sammy. Cross-chain transactions, atomic transactions on multiple chains that are executed by the chains finalizing a block at the same time on multiple hierarchical chains. In future videos, we will see cross-chain transactions on same-level chains and much more. This tech is possible due to our continuous innovations on blockchain tech designs. I remind you all that this effort is made 100% as self-funded volunteer effort over a course of 8 years. And we will achieve tech that can revolutionize human and digital consensus soon.